All right, it is day 16, getting ever closer to the end. Oh, look, a maze. It's time for the Reindeer Olympics. This year, the big event is the Reindeer Maze, where the reindeer compete for the lowest score. Event's about to start. Reindeer start at S facing east and need to reach the end tile marked E. They can move forward a tile at a time, but never into a wall. They can also rotate clockwise or counterclockwise 90 degrees at a time, increasing their score by 1,000 points. To figure out the best place to sit, you start by grabbing a map. Here's a map. There are many paths. Best path is a cost of 7,000, pathfinding again. This can be achieved by taking 36 forward and turning 90 degrees a total of 7 times. Note the path shown above includes one 90-degree turn as the very first move. Okay, so I feel like this is pathfinding, but every position is also connected to itself through a rotation that costs something. So forward is the only way to go, right? You can only move forward. Only forward one tile at a time. So we end up somewhere and we can either go to this tile or we can turn. We can only turn 90 degrees. Can we turn in either direction? Clockwise or counterclockwise 90 at a time. So theoretically, you could just spin in a circle forever. But I think we'll pull this in. We'll use a pathfinding algorithm. We will pathfind with forward. And what will our nodes be? Our nodes will be maybe the direction of the next node. I don't think if we use pathfinding the crate that if we use this, then we have any dependence. There's no checking, as far as I'm aware, of like other paths. A node will never be included twice in the path as determined by the EQ relationship. So, I want to be able to keep the like facing direction. I think we can hack this in. I think that if we use a node that is a type of position and like intended direction, then we could do that. So let's start with this input. This input has a score of 7,036, and we have to have, how do we calculate scores? Scores are, a forward tile is 1 point, a rotation is 1,000. So this reads 7 rotations, 36 forwards. Got it. We'll create day 16 here, get ourselves into day whatever, I guess. We could RS test this. We have multiple examples. Do we only have 2 examples actually? We have this one and we have this one. So I did a cargo add -p for the package. So our package is day 16. And if we look at the cargo toml, that adds pathfinding with aversion and glam.workspace because it's in our workspace. Yesterday was also this same kind of grid with different characters, but still with walls. So we've got RS test with a case that starts with the grid and ends with, or not starts with the grid and ends with, uses the grid as input, has a result of this. Same thing for case 2. This gives us our input and our result. And we'll just assert that processing the input gives us the result. If I remember correctly, we also have day 6 had a very similar parser. So maybe we just yoink this in as the parser we start with. Obviously, these are not going to be necessarily correct. We need to do, we would need to do S for starting position and E for ending, right? So at least for our, I think we're going to use nomlocate too, actually, now that I think about it. So we'll use cargo add to do that again. And you can see adding nomlocate parentheses workspace. That means it'll be nomlocate.workspace equals true. So our parser does a separated list line ending many one token. Token, if I remember correctly, is any of the potentials. So dot hash and then S and E would have to go in here. Let's get just work day 16 going on in here. The return value is wrong because I have done things. This is ending position. And then those are technically walls. So if we do starting ending walls as debugs, and then we kind of like to do this, this should run and give us something. So this is for case 2. So we start at 115, we end at 15.1. That's interesting. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's interesting. That doesn't sound right. Wait, 0? Oh, that's the first one. Never mind. So 15.1, or rather 115 is the starting, and then 15 again, so 115. Let's just make sure that these, actually, literally does not matter that there are any IDs or like any XY positions for these positions, because we only care about counting the forward steps and the rotations. So this should be good. I think those two are also good. So we end up with all the walls. So actually for our return value, I can make this like an impromptu struct, right? I can do like input, start as an IVEC2, end as an IVEC2, walls is this hash map, IVEC2 car. I think that walls is always going to be this. So we could actually hash set it because it's always going to be a wall. We don't have any other options and the walls don't move. So we're going to use a hash set here because we don't need the cars. So this allows us to do this and have our, I guess we shouldn't call this input. We should call this, I don't know, map or something. I don't know. I don't have a good name for it. So we have starting position, ending position, and walls. And this needs to collect into a hash set. And these will just kind of destructure these out. These are probably references or something. From iterator, IVEC2 is implemented for hash set IVEC2. Oh, right, because these, let's see, filter map, and we'll use this dot then some, not value, but position. And then expected tuple IVEC2 car part one map found struct part one map. Why is it expecting a car? Because I didn't change my function signature, because this should just be input map. And then this probably is a reference because we're debugging it. Debugging, no bugs. And then this is going to be like effectively our fully destructured map here. So we can just fill struct fields and we get an extra ending curly brace. Yay. So we have start, end, and walls in map. And one thing that I kind of want to start putting in here is this all consuming. So we have a parser here, right? And if we throw all consuming around our parse function and bring it in, then theoretically, let's go part one down here. And let's say there was like an S here, right? Then we get an error if we haven't parsed the full file. I think this is going to be useful for us. Yesterday, I made a mistake about not parsing the full input. So I think I'm just going to keep throwing all consuming in there. There's a warning about parse here, or not a warning, but a Clippy style lint. Oh, because, so I created pub, or I created parse as pub here. That just happens to be because I benchmarked this on day 6, if I remember correctly. So yeah, so parse now returns map as its value. We have start, end, and walls. We immediately destructure it, but I do kind of like this instead of just listing tuples. Once I get to 3 elements in a tuple, I kind of like to start naming them. And we've added all consuming here, which we could add anywhere, to make sure that we're consuming everything. So we could start taking this extra stuff like all consuming and the map error and stuff and throw it into our parser if we want to, since it's getting, to be a couple lines up here. Now, we've already used pathfinding, right, on day 13, like this. So we'll grab that. And the start node is start. So we don't need to do a start node here. This will be start. We do need to import this if we're going to use it. I think I want to pull it in from the prelude, not from directed. So I'm just going to pathfinding star there. And then we need to figure out what our positions are going to be and what the end is going to be. The end here is going to be end. And now we kind of need like a positional. So actually, I think this start is going to be start and like direction, right? And we already have direction. We've already written a direction like this over here. But this could also be an IVEC2 if we wanted it to be, in which case we always start by going up, right? The reindeer started on the start tile marked S facing east. So we face east. So this is going to be IVEC2X. And then our ending position is going to be like position and underscore, because we don't care about which direction we're facing as long as we hit the end. So this is going to be pos equals end. And then we need to figure out how to set up our next positions here. So we need to use the walls to do this. This is also position and direction. So the direction is going to be the next direction that we're supposed to go in. So let's say match on direction, maybe? No, we don't need to match on direction. So position plus direction, walls.get, and this probably needs to be a shared reference. Oh, this isn't get. We did a hash set. Contains. Let's get all of our parens right and stuff. It would help if we did next position equals this, and then we wouldn't need these extra parens. So if we do next position equals position plus direction, I'm not sure why we're getting so much red here. Oh, IVEC2 is not an iterator. Is that really the only issue? What if we comment this out? I feel like I'm somewhat surprised that that doesn't work. Unit is not an iterator. I guess this is a closure. So this closure, if we put to do here, returns unit. So I'm going to kind of shortcut that with this, I think. Oh, and we need to add the cost here too for any of these. So it would be this with a cost of, I don't know, 1 in this case. 1 if we go forward, 1,000 if we turn. Okay, so at the very least, we have something going on here. Next position, if walls contains, then do something else, we can move into that position. We need to have the option of doing both, right? So we need to have the option of next position, direction, same direction, 1, right? Because we're moving forward. And also, I think we need our turn right here. We need actually 2 more options here, I think. We could go forward, we could turn right, or we could turn left. So if we have a direction, right? Let's say we have like 0, 1, right? Going down on the y-axis. Then we need 1 and -1, comma 0. So I feel like it might be a little bit silly to look for this, but I wanted to look for something that would flip the 2 components. Because if we flip and negate, then that would work. Returns a vector that's equal to itself rotated by 90 degrees. So theoretically, what do we have? Position, direction dot perp, right? That is a function I've never used before. And this would be cost of 1,000. Oh, it expects a shared reference to an IVEC2? Why does it expect that? Hang on. I think perp should be creating a new IVEC for us. So the question is, oh, it's getting that because I think that we passed this in directly, and we should be passing this in as a value. So I think next position direction 1, that means we go forward. Position direction perp, rotate right. Negative direction perp, rotate left. Clockwise and counterclockwise. Ooh, my cursor's getting really laggy. I need to do a reboot before our next advent of code. Let's do vec next position direction. So if walls contains next position, then we can't move forward. If it doesn't, then we can move forward. So these are our 2 options, really. And I think this just goes forever. So the real question is, what do we end up with here? Result.1 is really what we need to look for. So let's do okay, result.1.2 string, because that should give us the lowest cost, right? Is that not what has happened here? Oh, sum. So this actually does need to return us something, or I think we've failed. So let's do an unwrap or an expect, and we'll expect a valid AOC result. And the question is, did these both just pass? I think they did. They look like they passed. So let's go make them both fail, just to, make sure that we see each one fail and each one pass. So that's case 2 passing, case 1 failing. So I think we're good here. Let's cargo run P. P is for package. Day 16 bin part 1. Parsing error, because there's new lines in the files. So this is our all consuming, which is nice. It's nice to see that actually show up. This is a Miette error, so it's got the context where we're processing part 1, and our parse failed with this parsing error. We could even go deeper in this if we had structured errors, but we don't, and I took a shortcut, so this is what we get. So that means that for parse here, we probably also want an opt line ending on the input. So at least now this is explicit. I like that it's explicit because we did make this mistake yesterday, or I made this mistake yesterday, not us. So let's put this in and see if we get a gold star. Sweet. Okay, now that you know what the best pass looks like, you can figure out the best spot to sit. Okay, so let's talk about what we did here. So for part 1, we have these 2 grids here. Same parsing deal as previous days, so I'm not really going to spend too much time on the parser. We've got hashes, which are walls. We've got E and S, which are starting and end positions. And we need to know the cost of getting from S to E in the shortest path. We use rs_test like we've done in previous videos with each of the cases, so we're doing table-based tests here. Our parser takes a nomlocate span. This span is actually not from nomlocate. We are type aliasing located span. And it's nice to be able to just write span instead of this whole thing. Because now we only need to change our input in one place. If you have a lot of parsers, a lot of combinators, it can be kind of annoying to go through all of them and change this if you use located span. So type alias is very nice. Means we can say input span here. This token is just responsible for getting the positioning of each of the characters that are possible. And in this case, we just parse everything. And I mean everything, including empty spaces. And then we get our positions. So we do a separated list of line endings of many of those tokens, and that gives us items. We could do this as an iterator and do the filtering on this earlier, but I didn't. There's an iterator example for like day, I don't know, 3 or something like that. Or maybe it was day 1, actually. We added this opt line ending here because I added an all-consuming parser when we use this. So just to make sure that we consume all of the input, because it's advent of code, and we are. Otherwise, we just take the items that we pulled out, which are all of the IVEC2s and cars. We look for the starting position, we look for the ending position, we filter out all the walls, we build a hash set of the walls, and we use this like intermediary struct because I like having names for things. The intermediary struct is like super lightweight. It's an IVEC, hash set IVEC, so we're not really adding anything in that sense. Here's the all-consuming that I was talking about. So we are destructuring the input and the map in a tuple. Inside of the map, we have a number of fields that we're pulling out. All-consuming gets wrapped around our parse function because it's also, those are both parser combinators or parsers, however you want to think about them. We pass it the input wrapped in our span type. We're mapping over the error. And that gives us the starting position, the ending position, and the walls. If we use our pathfinding algorithm with a starting position and a directional facing, then we can iterate over with that directional facing, check to see if the next place we want to go is a wall or not. If it is, don't walk forward. And if it isn't, have the potential to walk forward or turn. We used perp here for 90-degree turns for IVEX. Perp is not a function that I've used very often, but I think for IVEX, it is perfect in this case because then we don't need an extra like match or direction or whatnot here. And the example here is like if we have IVEC to like new 0, 1, right? We need this to be 1, 0, and also we need this to be negative 1, 0. So we need, left and right if we're facing up or down. So to do that, we take the direction, which is, 0, 1, we rotate it 90 degrees, which gives us 1, 0, or 0, 1 if we do the negative. We get both of them, and then we just find the score. So in that sense, it is pathfinding with some extra data in our node. So for part 2, every non-wall tile, S, dot, or E, is equipped with places to sit along the edges of the tile when determining which of the tiles would be best spot to sit. The most important factor is whether the tile is on one of the best paths through the maze. So you have to sit on the tiles or one of the tiles for the best paths, of which there could be potentially multiple, I guess. So you'll need to determine which tiles are part of any best path, including the S and the E. In the first example, there are 45 tiles, so all of these. In the second example, there are 64 tiles, because I think there are multiple paths. Like if we go up, down, and this way and that way. How many tiles are part of at least one of the best paths through the maze? That doesn't feel terribly much harder, in the sense that before I eat my words, let's not let's not call anything easy, let's say. But it feels relatively straightforward because we've already done similar things. What did we do? Was this right? So if we RG for all, we're going to RG for pathfinding. I don't remember which day it is. 13 maybe. Also 10. I think 13 is probably where we're going to find this. So if we look into 13, part 2 needed all of them, right? Oh, no, that was not the right day. Maybe it was 10. This gave us strongly connected components from, which I think gave us everything. So we don't want everything. We just want the best ones. I don't think we already get them. Let's check to make sure we don't already get them. I think this only gives us back one path possibility. So let's debug result here and then maybe panic or return okay to string. I always capitalize the S. I need to get out of that habit. So let's work on part 2 here. And then I guess I messed up. What did I mess up? Help return the semicolon. Oh, right, because I have a semicolon. So we get, I think, one path here, even though this is case 2, even though this is returning us, I think it's returning us a single vec. So we need a slightly different application of this. So we could use, I think, yen, which is using the same algorithm we were just using. K is the amount of path requests We don't really know how many there are going to be, so asking for a number feels weird. We could just do, like, quote, all of them. I think we could get by with doing this. I don't think we get to. Oh, if there exist less paths than requested, only the existing ones, if any, are returned. So this would allow us to do kind of what we want. We might have to post process it after that. A star, however, has A star bag, which will return us all the shortest paths. I think that's what we should move to. So start successors, heuristic. I guess for heuristic, we can just use like 0 or 1. I think if we don't have a good heuristic, that's not really a problem. Like it would be a problem in the sense that, like, don't love that we don't have a good heuristic, but if we just skip the heuristic, right? If we return 0, then A star solution, IVEC cannot be formatted. Oh, right, because this is an iterator now. So this is going to be like a collect into a vec so that we can like even debug it, right? I've tried a couple of things like iter and into iter on this A star solution struct that I thought were going to work, but they did not. So let's find out. This implements iterator. I thought I was going to be able to collect here. We're seeing a method cannot be called on A star solution due to unsatisfied trait bounds. So let's just specify this. You can see here that it says integer. So let's specify this as an actual number type and see what the compiler has to say about that. Oh, the method collect exists for tuple. We're not getting back what I thought we were getting back. We're getting back option tuple A star solution cost, where A star solution is the iterator. So result is actually result cost. And then this could be collected, right? Debug cost. And then probably my types just don't match up here either. Value of vec, IVEC2s cannot be built from iterator of item where vec is. So each of these is each of the paths. So if we iter here, I guess we don't need to iter here, but we need to map over this, right? And we get a path. And this path needs to be itered and mapped into each of the positions. So this is going to be position, and that would be direction there based on how we set this up. So it needs to be position. And then this turns into like a flat map, right? And we collect that into a hash set. Or rather, yeah, I think we collect that into a hash set. Let's see what that has to say. This is probably going to be a references issue. From iterator IVEC2 is implemented for hash set IVEC2, but we found references. So if we into iter on path, then we get IVEC2s, and we get 1148 here for the cost. The cost needs to be correct, right? 1148, and for part 1, 7036. So that works as far as our thing goes anyway. So set dot length dot toString, is that the right number? What are the numbers actually? Because I don't think I didn't pull in the new, let's see, 45 in the first example, 64 in the second. I think I see 64 for the second, so I'm happy about that. This is 45, this is 64, and we cargo run part 2 and hope it runs in some reasonable amount of time. And we submit and we get the gold answer. Cool. We're starting to see more of the 10. I think this is the 10th year of Advent of Code, if I remember correctly. So we see a 10 with a bunch of stuff in it. So for part 2, let's get rid of some of these extra things here. So for part 2, we didn't really change all that much. We do have the cost here, so I'm going to leave that there. But we basically changed our algorithm to A star because A star has not just like the yen algorithm that we were looking at. Yen has a limit on the number of shortest paths returned, but we just want all of the shortest cost paths. So A star bag will give that to us. And we use the same approach that we did before, where we just have a positional where we are and a direction that we want to move in. Same logic exactly. We just use a heuristic of 0 here because we don't really, like, I guess we could do some heuristic here, but the heuristic can't go higher than the actual cost of the path. And I can't think of a better heuristic to use because, I mean, I guess 1 would be a better heuristic because we have to move at least 1 more, right? But what happens if we're actually on that tile? I don't know. So left it at 0. We basically are just tossing away the heuristic for A star. And then that gives us back the tuple with a iterator of all of the paths and a cost, because they all cost the same because it's the lowest cost. So we take that iterator, which is this result, and we flat map. We go path for each of them into iter, turn it into the position without the direction because we need the unique positions, not that weird node that we came up with. Flat map to turn that into a single iterator of IVEC2s, collect that into a hash set. We could also do, was it the all unique from itertools? And this would give us the, okay, I guess we'll call this count. And if we run this again, we should get 426 again. If I typed this correctly, this needs to be toString. All unique isn't the name of the function. Unique, I think, is the one we want. We want to make them unique, and then we can count. So I have a hunch that unique probably does some kind of allocation itself. So collecting into a hash set and then using the length isn't really much different than unique and count, but both of them would work. And I don't think that either of them has enough of an impact to matter, right? So unique returns an iterator adapter that filters out elements that have already been produced once during the iteration. Duplicates are detected using hash and equality. So basically, like, where are those hashes being stored? Clones of visited elements are stored in a hash set in the iterator. So unique, you actually use as a hash set under the hood. So it was roughly doing the same thing we were, except it also produced all of the values. So that may or may not be useful. If we do it that iterator way, then I think that that hash set probably has to get filled incrementally, but it really depends on the implementation. So I think probably for our purposes, collecting into the hash set was the better option, but I don't actually know that for sure because I haven't benchmarked and tested and done anything like that. But for me, I think that if we have all of the IVECs and we're collecting those into a hash set and then we do .length, then we only have to do the collection into the hash set once and then we can length. But I don't know if unique, I don't know what the implementation of unique is kind of what I'm getting at. So may or may not be better. Who knows? But that's it for today. Kind of a short one. If you're still sticking with the advent of code, congrats on you, because I haven't looked, but not leaderboard, stats. But we are down to about 2,000 people right now. Obviously, day 16 is going to go up. This is, I think, 30,000 total. So we're down to about 30,000 people doing the last couple days, maybe 40,000 a couple days ago. So if you're still sticking with it, not many of you left. But if you're one of the people who is on, like, you know, a day 8 or 9 and you're coming to this video later, also good on you, because you get to do these problems whenever you want. So congrats to everyone who has made it through Advent of Code so far. And I will see you for the next, I think, 9 days. Have a great rest of yours.